Divide triangles on the basis of angles. We have right triangle, obtuse triangle, and acute triangle. And we have seen how in these three triangles, C square relates to A square plus B square. Yeah. For a right triangle, it is equal to, for an obtuse triangle, C square is greater than A square plus B square. And for an acute triangle, it's less than, where C is the largest side and the other two smaller sides. And on the basis of length of sides, a scalene triangle is one that has, in which all three have different lengths. An equilateral triangle is one, as we had covered, every angle and every side is equal, every angle equal to 60 degree. Side is typically A is what we use to denote the side. Isosceles triangle, two angles and two sides of, where angles and two sides in that triangle are equal. That's what an isosceles triangle is. Now, as I had mentioned in the beginning, I do want to cover a little bit of data sufficiency. So let me do that through this question. So anyone here who has not attempted a data sufficiency question yet, or who doesn't really know much about data sufficiency? Anyone here who doesn't know a lot about data sufficiency? Okay, I've just given audio controls to everyone, and I think someone's Saundarya, your microphone is, yeah, okay. So I just touching upon data sufficiency again. Typically, the format of a data sufficiency question is something like this. You have a question. In that question, you are given some facts, either directly in the question, through words, or through the diagram. Like in this question, the diagram gives you a lot of information. You'll see lots of diagrams for geometry, of course. So you have some facts in the question, followed by the question itself. Yeah. And you do not have to solve the question. That is not the idea. No need to solve or no need to calculate. You only have to check if the data is sufficient. That's the main question. Is data sufficient? And data sufficiency is checked through statement 1 and through statement 2. And there are a variety of ways in which you can use 1 and 2. You can use 1 alone, or use 2 alone, or combine the 2. Yeah. And all the different possibilities are sort of covered in these 5 options. 5 options that are standard, as I said in the beginning. Option A is that statement 1 alone is sufficient, but statement 2 alone is not sufficient. Yes. So if you can solve through 1 alone, then but not through 2 alone, then A is the right answer. B is the right answer if 2 alone is sufficient, but 1 alone is not sufficient. C is the right answer if you need to combine. If you must combine 1 and 2, which means neither statement alone is sufficient, then C is the right answer. D, of course, is the right answer when either statement alone is sufficient, and E is the right answer when by no means can you calculate the answer. That even together, even statement 1 and 2 together cannot help you solve the question. Yes? Can you solve question 1 now? Can you solve question 1? Okay, different answers. Saundarya, you should check your answer. Krishna, Lakshay, and Vinay have the same answer. Surbi has not yet shared her answer. Saundarya, please check your answer. Each is sufficient, indeed. So for each is sufficient, the correct option will be option D. Okay. So Saundarya, I hope you have rechecked and you've got your answer as D. Yeah, either one is sufficient indeed. So you know what I just want to touch upon right now is that one of the challenges of data sufficiency is that till the time you read statement one, it's fine. Most people don't make a mistake till the point they've read statement one. But what happens once you've solved using statement one? A lot of students, a lot of you make this mistake that while reading statement two, you are still taking. There's a memory trace of statement one, and you tend to assume statement one as factual information given in the question, which it is not. Yeah, statement one is a separate piece of information. So what you should be very careful about is once you've read statement one, just refresh. Just take that moment to refresh, reread the question, and then attempt statement two, taking it as a standalone statement, forgetting about statement one, so that you do not assume any information given in statement one, because this does happen a lot. Yeah, so I guess here it's clear that 5 PQ is equal to PR, both are equal to 5, so this must also be X degree. So if you get the value of any one angle, if you get the value of X, you will get the value of Y as well. So you can definitely solve this question using statement one, and even through statement two you can solve, because it is not just X plus Z that is equal to 180. It is also, sorry, it's not just Y plus Z, it is also X plus Z that is equal to 180. And therefore you can solve, because from these two combined you get X is equal to Y. So both statements alone are sufficient. Option, the correct answer option is D. Yes, this is good. Okay, that is very good. Let me cover congruency in brief, not jumping on not spending a lot of time on congruency. We had covered similarity in fair amount of detail. What do you remember about similarity? Because I want to build from similarity, build on, and then move to congruency. What do you guys remember about similarity? Audio control has been given to all 5 of you. Should you want to use it? What do you remember about similarity? When I say triangle ABC is similar to triangle DEF, what does it mean? Then the area is square time what? Saundarya, SSS, AAS are these types of congruencies. Let's not jump on congruency for the time being. Let's focus on similarity. Ratio of sides are equal, of course. That is the result. If sides are in ratio 1:3, then area is in the ratio 1:9. That's absolutely correct, Akshay. That is again a result. What is the meaning of similarity? Okay, let me summarize this. If triangle ABC is similar to triangle DEF, I'm not making any diagrams. We know, of course, all angles of these must be equal. All angles in the two triangles equal. Yeah. We also know that these are proportional, which means that AB by DE is equal to AC by DF is equal to BC by EF. Yeah. Sides proportional. We have seen this. In fact, let me just write this. AB by DE, I must have mentioned that it's very important to write or to express similarity properly. So ABC being similar to DEF means that the first two here, AB, and the first two there, DE, this ratio is equal to the other ratios, is equal to BC by EF is equal to AC by DF. Let's say this ratio is equal to K. Yeah, like mentioned by Lakshay, 1:3. This could have been easily 1/3. There is no problem. This could have been 1/10. This could have been 1/50. It doesn't matter. Yeah. Now, not taking 1/3 at this moment. When this K becomes equal to 1, if K is equal to 1, that is what congruency means. That is when triangle ABC becomes not just similar but equal as well. ABC becomes congruent to triangle DEF. Because then all sides of ABC become equal to all proportional sides of DEF. So, putting K equal to 1, you get AB equal to DE, BC equal to EF, and AC equal to DF. So that is what that is what the difference between congruency and similarity is. Congruency is just a specific type of similarity. So congruency means not just proportional but equal. So congruent triangles mean that all sides are equal. That is what finally congruency means. And all sides are equal in the sense that a pair of proportional sides are equal. Yeah, all sides are equal, not in terms of them being equilateral triangles, of course. But so yeah, this is misleading. Proportional sides are equal. Yeah. If you want to prove congruency, then this is all you need to do. Prove that proportional sides are equal, because that's the essence of congruency. And of course, we're already covered. I mean, similarity means equal angles. So if you have already proved similarity, you only need to prove for one pair of proportional sides. And what does that mean? Say if I had ABC, triangle ABC similar to triangle DEF, if I could only somehow prove that one pair of proportional sides, say AC, if I can only prove that AC is equal to DF, then my job is done. Because I know that AC by DF, where is it? Here, is equal to BC by EF is equal to AB by D. They are all proportional and therefore equal to 1. So even if you can prove one, you combine this piece of information and the second piece of information, and you get that the two triangles are congruent. Yeah, is this clear? And I'm going to talk about the different kinds of congruency, but in a sense, that is what congruency is. Okay, let me jump back. So the three types of congruency, important types of congruency are: number one, SSS. If all if all three sides of a triangle are equal, proportional sides are equal, and the triangles are congruent. So for example, if I am given that AB is equal to 3 and A dash B dash is also 3, if AC is equal to 4 and A dash C dash is also equal to 4, and if BC is equal to 6 and B dash C dash is also equal to 6, without a shadow of doubt, they are same triangles. That is what congruency means. You may remember in your NCRT or in your school books, you may have read that if you cut two congruent triangles, then they overlap. They can be put over each other and they'll cover each other. So that's the idea of congruent triangles, and that is encapsulated by this rule SSS, all three sides being equal. And then triangles are congruent, that is number one congruency. the number 2 rule is side angle side. So if any two proportional sides are equal and the angles between those two proportional sides are also equal, then the triangles are again congruent. So if AB is equal to A dash B dash, AC is equal to A dash C dash, and angle A here, let me say this is theta, were to be equal to angle A dash, this is also theta, then I would get triangle ABC is congruent to triangle A dash B dash C dash. So SAS is the other congruency. Yeah. There is another congruency. This is alternatively known as ASA or AAS. There's a slight difference between the two, but I'm giving you the gist of what these two congruencies represent. They basically represent similarity plus proportionality, plus equality of a proportional sides. So if the triangles are in some way similar, and if you can prove that the proportional sides are equal, or one pair of proportional sides is equal, then you get this kind of similarity. For example, here, angle A is equal to angle A dash, angle B is equal to angle B dash, and the side opposite angle B, which is AC, is equal to the side opposite angle B dash, which is A dash C dash. Yeah. So just this much, this will prove that the triangles are congruent. You can give it whatever name you want. This what I just explained is known as AAS. ASA is slightly more specific, but yeah, you don't really need to get into more details. So just prove that the triangles are similar, which of course, since two angles are equal, the third has to be equal automatically. So this angle will automatically be equal to this angle, angle C equal to angle C dash. And one side is proportional, or rather the proportional side is equal, then the triangles are congruent. And when I say the proportional side, I mean the side opposite to the equal angles. So the side opposite to B and the side opposite to B dash, if they are equal, then these are the proportional sides equal, which means that the triangle is congruent. Is this clear? Is this clear? That is all there is to similarity. That is all there is to congruency. These two rules. Okay, excellent. Yeah, this is not important. Congruency of a right triangle is not so important. Okay, this is a miscellaneous slide. Let's jump to, let me go back to our agenda. We've just covered the basics of data sufficiency and congruency. Let's have a look at some properties of circles. This is not the right slide. Circles. So yeah, I have a circle here. We typically use the alphabet O to denote the center of the circle. By convention, we use O. Of course, every point on the circumference, is at a distance of R from the center. Yeah. And the circumference, is 2 pi r in length. Area of the whole circle is pi r square. Area of a sector, this is our sector. So let this be point A, let this be point B. Yeah, on the circumference. Then area of sector OAB, this shaded portion. This is equal to, this area is equal to theta by 360 into pi r square. What is theta? This angle. This angle AOB is theta. Yeah. So theta by 360 into pi r square is the area of my sector, and length of the segment which I could have also written as length of the arc AB here. I could have written this as length of the minor arc AB, the smaller arc. So the minor arc is this length. Yeah. And the major arc is the remaining portion. This is the major arc AB. Length of the minor arc AB is again theta, as I said, this was theta by 360 into 2 pi r. Yes, you guys must have seen this before. Okay. Okay, yeah. Angles in a circle. Let's quickly cover some basic properties. Basic properties about angles. So, the angle subtended by just focus on the diagram for the time being. The angle subtended by this arc AB, minor arc AB here, on the other part of the circumference will always be equal. So AB subtends angle ACB as well as angle ADB on the circumference. Both these angles will be equal. So if this angle is theta, this angle is also theta. Yeah. In fact, if there were some other point, let's say this point is E, then angle AEB will also be equal to theta. Yeah, that is good enough, clear enough. Now, there is also a relation between this angle theta and the angle subtended at the center. So, in fact, let's say I take an angle B here. Then the relation between angle B and angle A is that A will be equal to the angle subtended at the center will be equal to twice of the angle subtended at the circumference. Is this clear? B will be equal to twice of A. And what does that mean? Let's just let's see this again. This means that if this is my arc AB, if this angle is 80 degree, then how much is angle ACB going to be? How much is this angle going to be? 40. Yeah. This angle is going to be 40. Good. Let's also see this the other way around. We've only been focusing on the minor arc. Let's say this angle is equal to 260 degree. Yeah. Let this be AB again. That angle is 260. How much is this angle going to be? How much is this angle going to be? How much is angle AOB going to be? Or yeah, let's not take O. ADB going to be? What is the measure of angle ADB? It is 130. Absolutely. This holds both sides. So think of major arc AB. So major arc AB subtending 260 at the center, it will subtend half of that on the other side of the circumference, not on itself. On the other side, on the remaining portion, on the minor arc now, it will subtend half of 260, which will be 130. Yes, is this clear? Let me show this one more way. Let's say this is CD. My major arc CD is subtending here 300 degree, let's say. And the major arc CD will subtend on the other portion of the circumference, on the minor arc CD, this angle. This angle will surely be half of 300. This will be equal to 150 degrees. This is 150. Is this clear? Very good. Um, okay, of course, sorry, very important, but I forgot, is we're talking about circles, properties of circles. Very important property of circle is that the angle in a semicircle is 90. Now, semicircle is half of a circle, which means, say, let this be A, let this be B. If AB is a straight line passing through the center, we'll talk about cyclic quadrilaterals on there. We'll talk about cyclic quadrilaterals, sorry. Yeah. So AB is a straight line passing through the center. What do you call AB? What is the term used? Yeah, it's a diameter. So a diameter divides the two circles into equal parts. Yeah, I guess that's not new for you guys. Yeah, I guess you know that already. So I can see AB as an arc that is subtending 180 degree at the center, which means that it will subtend on the circumference half of 90 degree. So this angle is 90, and since we've already discussed, every such angle will be 90. Every angle subtended by AB will be the same. So, so let this point, let's say this point is C. If ACB is 90, so is ADB going to be 90, yeah? Or so is AEB. Let's say this is point E, let's say this is point D. These are all 90 degrees. You must have seen this. Yeah, is this clear? This is important. So angle in a semicircle is 90 degrees, very important property. Let's move ahead. Basics about circles again. Chord. What is a chord? A chord is simply a line segment joining any 2 points on the circumference. So A and B are 2 points on the circumference. You join them via a straight line and you get a chord. Now, before I jump and explain about different properties of a chord, this is what a segment is. I haven't defined a segment yet. Let me define a segment. This is a segment. Yeah. So let me just take this point to be say D. ADBM, this portion, the shaded portion, is a segment. This is the minor segment for chord AB, and the remaining portion, this portion, is a major segment for chord AB. Yeah, you will probably not see this term a lot, the term segment, but if you do, you should know. Now, the very, very important property for a chord is that the perpendicular from the center, so O is the center, I drop a perpendicular on AB, OM is perpendicular to AB. Now, it bisects the chord, which means if OM is drawn perpendicular, then M is the midpoint, which means AM will be equal to MB. Yeah? Or the reverse is also true. The perpendicular bisector of chord AB will always pass through the center. This is also one way of seeing it. That you start from the midpoint of ABM and you draw a line perpendicular to AB, it has to pass through the center. Yeah. And what this does is this helps you. This gives rise to certain question or certain types of question, which is OA. Clearly, OA is the radius. OA or OB both are radius. Yeah. Let's say the length of the chord AB is L. Let me just take this to be. Let me take AB to be equal to L. Now, if I were to focus on triangle OAM, what is OM? OM is the distance of the chord from the center. Let me take that to be D. Then in triangle OAM, surely OA square, which is equal to radius ka square, is equal to OM square plus AM square. M we had already established is the midpoint, and thus R square is equal to D square plus L by 2 ka whole square, or L square by 4. AM is equal to L by 2, uska whole square, the whole square of that becomes L square by 4. Is this good? Is this clear? This is a simple relation, nothing to remember here. But what is important that this relation helps us calculate, one of the three. So if I've been given radius as well as the length of the chord, I can always calculate how far the chord is from the center. Or if I've been given the radius and the distance from the center, I can always calculate the length of the chord. Yeah, simple enough. Is this clear? Okay, very good. Other properties of a chord. The longest chord in a circle is the diameter. There's no shadow of doubt about it. Yeah, that's the longest chord. It is at a distance of 0 from the center, no distance. Also very important, equal chords are equidistant from the center, and they subtend equal angle at the circumference. So let me show you this using maybe a simple kind of diagram. Let's say this is chord AB. It is equal in length to chord CD. Yeah, if these two are equal, then of course, since we're talking about the same circle, they'll be at the same distance from the center. So this distance will be equal to this distance. Is that simple enough? Is that clear? And finally, if two chords intersect inside or outside the triangle, I'll show you how the outside triangle thing is done. PA into PB is equal to PC into PD. And what does this mean? This means that from the point of intersection, the length of the two ends. So from PA and PB represent the two ends of the chord. So PA into PB is equal to PC into PD. This is true not just if the chords intersect inside the circle. This is also true if they intersect outside. What does that look like? Let me show you. Say I have a circle. Yeah. So let this be chord AB. Let this be chord CD. Clearly, these are not, they don't look parallel. They haven't been drawn parallel. But they don't intersect inside the circle. But if we were to extend them, they would intersect, let's say, at point P. Yeah. Now that they are intersecting at point P, now the rule stays the same. PA into PB is equal to PC into PD. So from the point of intersection, which you get either inside the circle or by extending the chords and getting the point of intersection outside the circle, the product of the point of intersection from the two ends of the chord will be equal. Is this clear? Yeah. In fact, let me just also mention here that if from this external point there were a tangent drawn to the circle, let me draw a tangent from this external point, and let the point of contact of the tangent to the circle be PT. I hope you know that the tangent touches the circle, it doesn't intersect the circle, it just touches the circle at one point, something like this. Yeah. So if PA into PB is equal to PC into PD, it is also equal to PT square. where from that external point, PT is the tangent. Is this clear? Is this good? This is important, and I would of course want you to remember this. Okay, cool, very good. Let me know if you guys have any doubts here as we move ahead. Okay. Tangents. A tangent is a line that touches the circle at only one point. How is it? It's not OT, it's PT square. See, just by simple understanding, if CD, if I were to ensure that PC, if I were to slowly and steadily, so this was PC. If I were to slowly and steadily now shift PC right so that it becomes a tangent, then won't PD and PC approach each other in lengths? They will keep becoming equal, and thus I mean you can easily get this from I think you get it through integration, but then I'm sure there is another way of getting this. And I guess simple understanding, just understanding that as C and D approach each other, they become square of a value, very close to each other. Okay, tangent is a line that touches the circle at one point, of course. So let me take this external point to be P. Very standard convention, you always take that point to be P. Let this point to be T. So firstly, from any external point, you can always draw two tangents to a circle. You can draw PT and PT dash from an external point to a circle. You can draw two tangents and they'll be equal in length, which means PT is equal to PT dash. Yeah, and of course, one of the basic properties is that on any tangent, if you draw the line joining the center and the point of contact, then this radial, OT is the radial, will be perpendicular to PT. Or in fact, if I were to join O and T dash, the other point of contact of the tangent from P, then OT dash will also be perpendicular to PT dash. Yeah. Is this good? Okay. Now let me share a couple of other properties here. So yeah, let's say this is property 1. Let's say this is property 2. Yeah, so this is a part of property 2. PT is equal to PT dash. Very important also. This line TT dash. Yeah. This line is bisected by PO always. So PO will always bisect TT dash. It will it will divide TT dash in equal parts at 90 degree. So it will not only bisect, but OP will also be perpendicular to TT dash. Please do remember, this is a very important and a useful property. I'm sorry, the diagram is not so good. So let me do it again. But do remember this is. Yeah. So this length from the point of intersection, these two lengths are equal. Is this clear? a rather important property, and it gives rise to some wonderful questions. Some good questions, yeah. Okay, maybe we can do a couple of questions on triangles right now. Why don't you have a look at the three questions here? Question number 3 is on data sufficiency. And thereafter, we do another couple of questions. Please try question number 1, 2, and 3. Um, question 1 also needs a little bit of trigonometry. So if you are able to solve it, good. Don't fret. If you're not able to solve it, we are yet to cover trigonometry in detail. We are yet to cover trigonometry, so yeah, don't worry if you are not able to solve question. Just give it a go, and we'll discuss it. So done with these three questions? Done? Should I move the slide to the next? If you haven't, just take a snapshot, please. We'll discuss this in the end. Please just take a snapshot. Okay, another two questions. There we go. And I will confirm the answers, of course, from Daria and Sulbi and Lakshya and Vinay and Krishna. Okay, let's finish this in the next couple of minutes if you haven't finished already. So, Sandhya, D means that either statement alone is sufficient in this question. This is question 4, since we had seen the last two. Let me just mark this as question 4 and question 5. If you've taken 1 and 2, there's no problem. This also needs a little bit of trigonometry, but I want to introduce that today a bit because I will cover trigonometry in detail in the next session. So I hope these two questions. Okay, very good. I guess most of you have solved it. Any issue with question 5? Question 5 is most definitely option A. Okay, excellent. And 4, question 4 is also absolutely correctly answered by all of you. It is D, which means either statement is alone to answer the question. Any problems with 4? Okay, excellent. So I am assuming that you understand. Let me just go to take a board. Yeah. So maybe I can introduce a bit of trigger here, already. Just a little bit because I will cover this in detail later as well. So if I have a right triangle, let's say this is theta, this angle is theta. Let me also label this triangle. This is triangle ABC. Internal angle C, interior angle C is theta, or angle ACB is theta. What is sine theta equal to? And what is cos theta equal to? Let's just focus on these two for the time being. What is sine theta and cos theta equal to here? Sine theta is the side opposite by hypotenuse. Absolutely correct, Sondra. It's AB by AC. And cos theta is the adjacent side, the side adjacent to the angle, BC by the hypotenuse, BC by AC. Yes, excellent, very good. And of course, tan theta is sine theta by cos theta. We'll cover that in greater detail later. But I just want to take you through these two triangles. This is important. The two triangles that are known as 30, 60, 90 triangles. Let's say this angle, let's take this to be C, this to be A, this to be B. Angle B is 90, angle A is 60 degrees, and angle C is 30 degrees. Now, these a 30, 60, 90 triangle. This is what triangle ABC here is. This has a set ratio. There are set ratios for this, and those ratios are the side opposite angle 30 degree. If that were to be 1, then the side opposite 60 degree will be √3, and the side opposite 90 will be 2. So that's the ratio. You already know that the smallest side is opposite the smallest angle. So the side opposite 30 will be 1, opposite 60 will be √3, opposite 90 will be 2. That's the ratio. 1 is to √3 is to 2. Yeah. So 30, 60, 90 triangle has a ratio of size 1 is to √3 is to 2. And the 45, 45, 90 triangle, the only other triangle of note, is as you know, of course, 45 degree and 45 degree, the sides opposite will be equal. The ratio of sides here is 1 is to 1 is to √2. So the 45, 45, 90 triangle has this ratio, 1 is to 1 is to √2. Yeah, this is good. This will be useful in a lot of data sufficiency questions, actually. You do need this in data sufficiency, otherwise it's a bit of a headache. Okay, that is cool, very good. So jumping back to our questions. I'm assuming you don't have any problem in question 4. You already said you said it's D. Any problem in question 1? Any problem in question? Okay, then let me take question 1. What do we know about question 1? So I am assuming that you. I'll solve all three. Don't worry. I'm assuming that you. Yes, indeed. I'm assuming that you heard what I just shared about the two types of triangles. Now here, since CD is parallel to AB, I think it's absolutely clear to everyone that X is 30 degree. This angle is also 30 degree. Yeah. And since we have to calculate the perimeter of the shaded portion, what we essentially have to calculate is CE, minor arc CE, plus BC plus BE. That is what we have to calculate. And of course, BC will be equal to BE. BC will be equal to B, and we'll see what and how that is so. Let me go to let me just open another board. Okay. Now this, just drawing this, the relevant portion and ignoring the rest. You have to calculate the perimeter of this. Now what we do know, this was our diameter here. AB is our diameter. Now what kind of triangle is triangle ACB? This is A, this is B, this is C. What kind of triangle is triangle ACB? We've already established, and it's already given that AB is the diameter. What will be the measure of angle C? C is absolute, it's a right angle. And thus, C is on the circumference. This is the right angle. We've just seen this angle is 30 degree. Yeah, which means that this angle must be 60. That angle is 90. We have just seen the ratios of sides in a 30, 60, 90 triangle. What was the ratio? Angle opposite 30. If that is 1, then so side opposite 30. If that is 1, then side opposite 60 is root 3, and the side opposite 90 is 2. Yeah, and thus AB, since the length of AB is actually 10, that means that AC must be equal to 5. It must be half of AB. This must be 5, and CB must be root 3 by 2 times. AB is 2, BC is 2 by root 3. Since AB we know is 10, BC can be immediately calculated to be 5 root 3. Yeah. Yes? Vinay, do you still have a problem now? Is this question clear? Got it. Excellent. So you get BC 5 root 3. In the same way, you get BE equal to 5 root 3, because it's the same length. It's the same triangle. AEB is also a 30, 60, 90 triangle. And one sec, guys. Yeah, sorry. And thus you can calculate minor arc EC. Yeah, is option B. Yeah, exactly. So minor arc EC can be calculated because the angle that it is subtending on the circumference is 60. It's very simple. This arc CE is subtending angle 60. It is 30 each. Yeah. So I can say that the length of minor arc EC is 60 by 360. We had covered theta by 360. So angle subtended at the center is not 120. Oh yes, yeah. Sorry. Yeah. So you're right. Sorry. I just got a bit distracted. Everybody was moving out, and I have to close the doors. So this angle is 60. You're right. This is not theta. Theta is always the angle subtended at the center, which will be 120. So length of minor arc EC will be equal to 120 degree by 360 into 2 pi r. Yeah, so you can calculate now. R was, I guess R is 5, and you can calculate. Hang on, what was R? So it has a radius of 5, so 1 by 3 into 10 pi. It's 2 pi r. Yeah, 10 pi by 3. So the answer is going to be, your overall perimeter is going to be 10 pi by 3, which is the length of the arc, this CE, plus BC plus BE, which is 5 root 3 plus 5 root 3. Which is again 10 root 3. So 10 root 3 plus 10 pi by 3, which I guess is option Yeah, it's option D. I'm sorry, it's not option B. It's not option B, guys. It's option D. Clearly, it is not option D. Sorry, it's not option B. It's option D. Yeah. No problem with question two. Is question two clear? PC into PD will be equal to PA into PB. Let's check answer for question three. Two is clear. I think X is 13, wasn't it? Yes, it is 13. The answer to X is 13. Very good. Question number three. So what are your answers to question three? Okay, you have different answers. Now, I hope you understand. Okay, let's check. I hope you understand that when the wheel does a full circle, when it covers the circumference once, or when it covers 360 once, it's moving by a circumference. So if you're talking about a tire, yeah, and say this is the point of contact of the tire with the road, then by the time this point comes back again, say here, the distance, the linear distance moved by a tire, this is important, this is 2 pi r, where r is the radius of the tire. Okay, let's check the answer. Yeah, the question is simple. There's a car being driven. It does not slip, which is very important, which is what I've just explained. If the tire doesn't slip, then in one circumference, by the time the same point is back, the linear distance covered is 2 pi r. How many rotations does each tire of the car make in 10 minutes? Now, if the car is traveling at 50 miles per hour, if the car is traveling at 50 miles per hour, can I calculate how many rotations it makes? I cannot. What I can calculate from statement 1, so let me go back to the board. I can calculate the distance moved by either tire, only from statement 1. Distance is equal to speed into time. You have the speed, you have the time. So I'll be back in 30 seconds rather. Why don't you check? Clearly, statement 1 alone is not sufficient. Let's check if you can solve using yeah, sorry. So statement one alone is not sufficient. It just gives you the distance moved. Since speed is given to be 50 miles per hour and time is 10 minutes, which is 1/6 of an hour. Yeah. Now, what does statement 2 tell me? You must forget about statement 1. We only know that it has moved. The fact we know is that the car has moved for 10 minutes. Each tire has a radius of 20 inches. Now, this again doesn't tell us much. This doesn't tell us anything actually, because statement 2 is giving us the radius, which means that we know that the distance moved in one rotation. We can calculate the distance moved in one rotation, which is 2 pi r. But what else do we know? We only know that time is 10 minutes. And therefore, you have nothing connecting the number of rotations with the time. And that connecting thing would have been the speed. You need to know the speed. Is this clear? So until and unless you combine statement 1 and 2, you will not be able to solve this question. And how will combining statement 1 and 2 help? You have the distance 50 by 6 miles. You know that this total distance must be number of rotations. Yeah. So a certain number of rotations into 2 pi r. Now you have the distance, you have 2 pi r because you have r from statement 2, and therefore you can calculate the number of rotations. Is this clear? What I've done here is I have taken total distance covered to be distance covered per rotation into number of rotations. It's very simple. Now what's the distance covered per rotation? 2 pi r. This is what 2 pi r is. And we can calculate the number of rotations if we know the total distance, which we do from statement 1. So combining both, I can get the answer. No need to calculate, no need to do anything else any further. Don't waste your time on data sufficiency questions, spending time calculating. It is not needed. You combine the two and you get answer C, and C has to be the right answer. Yeah, is this good? Okay, very good, cool. I'm happy. Let's jump to. I do have lots of questions for you, but I'm not. I didn't want to cover circles completely today because I wanted to focus on your doubts. So we've seen a few properties. There are many properties, many miscellaneous and important properties that we haven't seen. But let's just consolidate what we've already learned so far and the questions that we have covered so far. And I'm going to open the documents I'd shared with you. So yeah, let's have a look at that. And let's see. I think I'd shared this document with you guys last time. Have you seen this set of questions? Yes. Have a look at these questions and let me know which question you have a problem in. Please have a look at these questions and let me know which question you have a problem in. So in fact, let's just solve some of these questions together. Question 8, yeah. Question 8, how to go about question number 8. Did anyone try question 8? I'm giving you 30 seconds. Read it and let's discuss. Let's see how. Don't stall. Don't solve. Just tell me how you would solve this. And of course, you guys have audio access, so feel free to speak if you want. How to go about question number 8. Okay, I have not received any answer. One of the ways of doing it, and for this question, the rather tedious way of doing it is options for such kind of questions. You can always take options. So what would that mean? If I have to find the third angle is actually the angle in the middle, the median angle, because the question talks about the largest and the smallest angle. Okay, where's my pen? Sorry, 1 second. Okay, yeah. Let's open it here. I don't know why it's not responding. So yeah, of course, option is one way. So I can start by taking the third angle. Am I audible? Yeah, I don't know why the screen is not working. Okay, it's working here. I think there's probably a problem with the sheet. There's probably a problem with the sheet. Let's check it. Yes. So it's working on the board. So I'll probably solve that question on the board. Yeah. Now I could have started with 40. Just put 40 as one of the options. So I want to take you through the worst possible way of doing this question. Question number 8. So if that angle were to be 40, be the middle angle, that would leave the sum of the largest and the smallest angle to be 140. Yeah. Now, since you have been given some ratio, 23 times the largest angle is equal to 42 times the smallest angle, it means that 23 times largest is 42 times smallest. Just solve this. You have two equations, two variables. Use this to get values of largest and smallest, and your answer will be correct if the order is indeed that there is an angle, the largest angle is indeed greater than 40, and the smallest angle is indeed less than 40. That alone will give you the answer. If, of course, the smallest angle now comes out to be greater than 40, then your answer is an incorrect one, because then it's no longer the smallest angle. Yeah. So this is approach 1 using options. The rather more easy approach, the easier approach for such questions, because these form of question types, is always focusing on this relation directly. If 23 times the largest angle is equal to 42 times the smallest angle, just assume that these angles have natural number values. Just check. This method is more trial and error than anything else. So let's put the largest angle to be some multiple of 42. Yeah. So now the largest angle can't be 42. The largest angle of a triangle has to be greater than 60. It can't be less than 60, because otherwise you will not get a sum that is 180. So let's just take the largest angle to be a multiple of 42. Let me assume the largest angle to be in the next multiple, 84. I put that in this relation. I get the smallest angle to be 46. Yes? I'm not using options now, yeah? That was approach 1, options. Now the approach 2 is trial and error by assuming the largest angle to be a natural number, keeping it simple. And now if you have 84 and 46, just find out what the third angle is going to be. Let me call it T. The third angle is, of course, going to be 180 minus 84 plus 46, which comes out to be 84 plus 46 is 130. Is it? Yes, it is. So the third angle comes out to be 50. Now, purely on the basis of the values that we have, the smallest angle is indeed less than the third angle. 46 is less than 50. Largest angle is, of course, more than 50. So their order is correct. Let's now just look at the options. Do we have 50 as one of the options? We do. So option B must be the right answer. Is this clear? Vinay, is this clear? Okay, cool. Jugaad hai, this is Jugaad really, this is nothing else. But this Jugaad works for such questions. This is a particular question type where it works. I'm also interested in question 2. Were you able to solve question 2? Were you able to solve question 2, guys? Any problem with question number 2? Did you solve it? If you haven't, just try. Let's just try it right away. Try and let me know the answer to question number 2. (108x). No, it's 10 and x. Of course. In an obtuse triangle with sides 15, 10, and x. 3 sides. I hope you do remember the properties of an obtuse triangle. Yeah, c square is greater than a square plus b square. Eight and 11. Okay, maybe from statement 1, yes? Okay. Statement 2, what about statement 2? Does statement 2 give you a proper answer? Z is the root of the equation z cube minus 19 z square plus 88 z. I don't know if you've solved this. You may find a proper answer through statement 2. Mm-hmm. Yeah, 0 can't be possible. X has to be greater than 5. X has to be greater than 5, so 0 is not a possibility. So of course it's either 8 or 11, which also suits 1. So the answer is E, absolutely correct. Yeah, so the option here is incorrect. The answer option is not D. The answer has to be E. You guys have the right answer. I know what the problem in this question is. This is supposed to be an acute triangle. This is not supposed to be an obtuse triangle. Because I made this question, I remember now. This was supposed to be an acute triangle. Yes, x will lie between 6 less than equal to, yeah, it will be greater than equal to 6, less than equal to 24. And of course, from statement 1, you get the limit 6 to 13, that x has to be 6 to 13. But then, of course, you also need to check for an obtuse triangle. 15 square should be greater than 10 square plus x square. And you can still get 11. 100 plus 121 is 221, still less, yeah. E means that you can't solve the question, even using both statements alone. Yes, indeed, it's on the right. Okay, cool. I'm happy you guys got, all of you got the right answer. E is absolutely the right answer. Question 12. Okay, let's switch our attentions to question 12. So the diagram for this wasn't given. I am giving you the diagram right now. We'll not solve it right now. I want to move to rather more important questions. Question number 12 is also important, but it's relatively simple. So let me give you the diagram for question 12. And it's a very, very simple diagram. L1 is parallel to L2. And these angles are, this is angle A, this is angle B, this is angle C, this is angle D, angle E. Okay. This is angle E, this is angle F. E, F, G, and H. Yeah. L1 is parallel to L2. This is what the essence of question 12 is. Please take a snapshot of this if you want. Take a snapshot of this and you can save it with you. It's very simple. It's L1 parallel to L2, and it's, you know, in a sort of circular or a semicircular manner in A, B, C, D, and then E, F, G, H. And of course, the question remains. This question, do try this. It's a decent question, not the most difficult or the most challenging of questions, but yeah, I guess it's doable. Any problem with 9, 10, or 11? Any problem with 9, 10, or 11? How did you solve question number 10? I would be interested in how you solved question 10, not the answer. Not very concerned about the answer. How did you solve question 10? Or how would you solve it if you haven't? Okay, did you realize that question number 10 represents, the sides of question 10 represent a right triangle? This is, these sides are a multiple of the triplet 5, 12, and 13. Do you know anything about the, not the ratio, but do you know anything about the in radius and the circumradius of a right triangle? I think we covered that last time. Do you know anything about the in radius and circumradius? Yes. In radius plus circumradius is a plus b by 2. And what is r? What is circumradius equal to? Circumradius of a right triangle is equal to hypotenuse by 2. And there you have it. So no need to spend too much time. You know, some people use all sort of funny things. They calculate the area of this and then use the area formula. Because you don't, unless you recognize this is a right triangle, you won't be able to solve it. And once you recognize, then use the relation just shared by Lakshay, which is in radius plus circumradius for a right triangle is a plus b by 2. Sum of perpendicular sides divided by 2. Yeah. So I don't think you should have a problem with this question. You should be able to solve this question easily. The circumradius, of course, is hypotenuse by 2. So 26 by 2, that will be equal to 13. R will be equal to 13. Small r will be equal to 24 plus 10, 34 minus 26 by 2, 8 by 2, 4. Okay, cool. So I guess no more problems here. Let's jump to practice sheet 1. Tell me what problems you had here. Any problems with triangles practice sheet 1? Okay, very good. No problem in these two questions. So yeah, I had mentioned do not attempt this question. Okay, what kind of triangle? What kind of triangle has its circumcenter outside the triangle? Outside the area of the triangle? Yes, indeed, Vinay. So the circumcenter for which a triangular light lights out the area is obtuse. So essentially, the question wants to know which of the following options from A, B, C, and D represent an obtuse triangle. Okay, cool. We will try question 2. I'm surprised none of you said, yeah, so 4, 7, 6, and also 2, 3, 4, 7, 6. No, it will be 2, 3, 4. Lakshay, for question 7, the answer is option D, not option A. Did you try question 2? Question 2 is a good question. And this is not the time to try it, I'm sorry. If you haven't tried this yet, okay, somebody has tried it. So I'm assuming none of you have a doubt here, because I suspect you haven't tried this. If you have, good. If you hadn't tried this, it's a good question. We can discuss it later. But the two properties this is based on is, of course, the property of a right triangle or right triangles, and the other property is the intersection of medians. Just to give you a hint, do try this at home later. So property of a centroid and property of a right triangle should help you solve it. Okay, let's move to the other sheet. Did you try question 4? In the previous sheet, yes, Lakshay. Feel free to use a microphone, if you have 4, 6, 10, 12, 13. Are you talking about question number 4, 6, 10? Oh my God. 4, 6, 10, 12, 13. We just discussed, I think. Okay, I have to go back. Well, this sheet doesn't have 4, 6, 10, 12, 13. I think, okay. I think this sheet has 4, 6, 10, 12, 13. Okay, are you talking about this sheet? Practice sheet 2, Lakshay? Is it the sheet you're talking about? Is this the sheet you're talking about? Okay, please do check. The others, Vinay, I think you did have a few doubts. Let me know which questions you have a doubt in, which sheet you have a doubt in. Okay, question 5 and 6. Let's take question 5. I had mentioned the thing about question. Okay, the thing about question 5 is based on trigonometry, and I had given this question, but I did not really expect you to answer this question. So I will take this. I'll probably introduce this question again once we cover trigo. So I would ask you to hold your doubt for the time being, but to give you a hint, just take this angle to be theta. Take this angle to be theta, and since you know this angle is 90 degrees, you will find that you can break all other angles in terms of theta. All other angles will be either theta or 90 minus theta. And since, of course, sine theta is a fixed value, it's a constant, that will help you calculate everything you need to calculate in this question. That's a hint. You can try it. Once we cover trigo, I'll take this question up again. Don't worry. Question 7, there is, this again can be solved using trigo, but I remember there were other options that made it easier. Yeah. So I will ask you to hold question 7 for the time being. Let's just forget question 10. Question 7. simply because in the snapshot it doesn't show the other options. So let's just hold question 7 for the time being. Sorry, forget about question 7 for the time being, and I hope I remember to introduce it during Trigo. I'll definitely take up question number 5. Okay, question 14 and 15. 14 is a lovely question. It's a great question. I'll take a 15 as well. Let me take a 15 first. The sides of a triangle are in the ratio 13:14:15, and its area is 336 square feet. Now, 13:14:15 does not look like a right triangle. It is not a right triangle. It does look like, and it is clearly an acute triangle. If its area is given, the only way to calculate this is using Hero's formula. So how can you calculate this using Hero's formula? You know the area. You can take the three sides to be 13x, 14x, 15x. Lakshay, is that sufficient enough for you? Let me take the three sides to be 13x, 14x, and 15x. Find the area of this using Hero's formula and equate it to 336. Yeah. This may seem like a rather long question. It's not. It's actually not. You will be surprised at how those values of 13x, 14x, and 15x play. It's not a very long question. I can guarantee. So yeah, that's how this question will be solved. Let's have a look at this question. The question number 14. So what all do we know about question number 14? ZY is parallel to PQ. ZP is parallel to QR. Now we know that XY is equal to 2. XZ is equal to 4. YP is equal to 3. And you need to find, where is it? XR. Okay, cool. Now, so anyone who's seen this question, give it a go if you hadn't already. And Lakshay, of course, I'm solving it for you. If YZ, if XY is parallel to PQ, can I not immediately say that XZY will be similar to triangle XQP? Can I not immediately say if XZ is 4, then ZQ will be 6? Since XZ is to ZQ will also have to be in the same ratio 2:3. Is this something that is clear? Yeah. I'm just using similar triangles. XZ by XQ will be equal to XY by XP. Which is also another way of saying XZ by ZQ will be equal to XY by YP. It will be the same, and that gives me ZQ equal to 6. Just use similarity first of all, calculate ZQ. Then, what else do we know? We know ZP is a parallel to QR. And what does that tell us? Again, it means that this is to this is again in the ratio 2:3. And since ZP is parallel to QR, again in triangles XZP, this triangle will be similar to XQR. Is this clear, Lakshay? And what will be the ratio again? 2:3. So XP is to PR will again be in the ratio 2:3. So if XP which is equal to 5, if this is equal to 2 parts, PR comes out to be 7.5. And thus XR comes out to be 5 plus 7.5, 12.5. Yeah, 15/2. Is this clear? Let me know what other doubts you had. Which other question did you have a doubt in question number 18? How many obtuse triangles with integral sides of 23, 15, and x are possible? This is actually a fairly straightforward question, given that we have covered such questions. First of all, establish the limit of x. Now, x can't be greater than 23 plus 15. X has to be less than 38. But it must also be greater than 8. Since 15 plus 8 has to be greater than 23, I get this limit that x has to be greater than 8, or in other words, it has to be greater than equal to 9. Since it is a integer or a natural number, it has to be a positive integer. And thus, x will be greater than equal to 9 and less than equal to 37. Is that clear? This is step 1. No, absolutely. Step 2. Step 2 is checking for obtuse. Step 1 was just making sure that our side, that x gives me a triangle. Just to ensure that I can form a triangle with x, this is the limit 9 to 37. The next step is checking for obtuse. And I think I mentioned in one of the examples, always check for acute or obtuse by taking two cases. Those two cases will be, assume that x is not the largest side. Or in other words, assume that the largest side is 23. Once you assume that the largest side is 23, you know immediately that for an obtuse triangle, 23 square has to be greater than 15 square plus x square. Yes? So doesn't that give you some value of x? What does that give you? 23 square is equal to 529. So 529 minus 225, 15 square is 225. This has to be greater than x square. 529 minus 225 is 304. X square has to be less than 304. And also it is an integer, it's a natural number. This gives you that x has to be less than equal to 17. X is less than equal to 17. Since 17 square is 289 and 18 square exceeds 304. 18 square becomes 324. So x has to be less than equal to 17, and of course it had to be greater than equal to 9. So this gives you not 8, 9 values. This gives you 9 values. Yes? Now what's the second part? What's the second assumption? The second part of this is, so the second part of second, let me call this A. Part B will be very simply assuming x as the largest side. Let the largest side be x. Will you be able to solve now, Lakshay? And here you assume x square will be greater than 23 square plus 15 square, while at the same time being less than equal to 37. So match these two and you should get your answer. Yeah. Okay, very good. Any other doubt, guys? Any other doubt in this sheet? Okay, I'm pleased. Any other doubt in any other sheet? Vinay, Lakshay, guys, I don't know if the others have solved questions at home. If there are no other doubts, then you call it a day. If you do have doubts, then I'm here. Previously shared sheet this week. Which was the sheet? Okay, let me check the previously shared sheet, because I don't remember which sheet you're talking about. I'll take a minute to check which sheet that is. Um, I- okay, are you talking about questions on no, it's not. On quadrilaterals, Soundarya? Polygons, yeah, okay, okay, okay. The sheet on polygons. Yes, I did. I do want to discuss those. Let me just. So, can you specify which questions you have a problem in, Soundarya, and I'll just take those up. Because मुझे एकदम से sheet नहीं मिला. I'm not able to search. I'm not able to find that sheet in my on my email. But of course, if you you know if you tell me which question you have a doubt in, I'll search and just specify the question you have a doubt in. 1615. Okay. I think this should be it. Okay. Yeah. Is 16 one of is that the regular polygon question, and is 15 the one on with regular pentagon, Sandra? Okay, excellent. Okay, both are good questions. It's good that you reminded me because these are questions I wanted to discuss. I don't know why these have not been. Uh, why are they not showing here? I thought I had uploaded these, but I clearly haven't. Okay, I haven't uploaded them. It's okay. Let me take those questions on. Let's just close all this. Also, it's not this sheet either. Sorry, just take a minute. Okay. Yeah, so I would request everyone else to pay attention here because these are good questions, and these are definitely questions I wanted to discuss. Um, so, question number, let me take up question of 16 first of all. So, here's my hexagon. And it looks like a hexagon. Uh, let this hexagon be A, B, C, D, E, F. Now, what I want you to remember here is, I'm sure I must have mentioned, AB is parallel to not just ED, it is also parallel to FC. Yeah? And similarly, CD is parallel to not just AF, it is also parallel to BE. I think I mentioned this earlier, yeah? We had covered this in the last class. So let me focus on quadrilateral CDEB. Let me present it to you in a different manner. So yeah, on the left I have CBED. What kind of quadrilateral is this? What kind of quadrilateral is CDEB? I know that CD is parallel to B. Absolutely, this is for sure a trapezium. And if this is a trapezium, had we covered the length of the midpoint of non-parallel sides? So I join the midpoint of CB and the midpoint of DE. Let's right now not focus, not say, not assume that they CB and DE are equal. Just what will be the midpoint? What will be the length of this? Let me call that PQ, because that is what PQ. If you have a look at question 16, that is what PQ represents. P is the midpoint of that side. In fact, it's mentioned in the question, and Q is also the midpoint. What is PQ equal to? We had covered that for A plus B by 2. Absolutely yes. So that will be equal to CD plus BE by 2. Yeah. If CD, which is the side of the hexagon, has been given to be 10, what will BE be equal to? What is BE equal to? 20. We had covered that if this side of the hexagon is A, then this straight line EB or AD or FC, this is 2A. So if A is 10, EB will be 20. And thus PQ, Saundarya, I hope that answers your question. PQ will be equal to 10 plus 20, 30 by 2 equal to 15. Yeah. And why is that important? Because now in the question given, in the diagram given, I have side of the hexagon 10. I have this side PQ. So I hope you also remember PQ is not just half of CD plus BE. PQ is also parallel to these two. PQ is parallel to CD as well as being parallel to BE. And thus, I now have another trapezium of side 10 and 15. And can I calculate their height? Now, trigonometry would have made this easier to solve, but we can still calculate it very easily because these two sides are 5 each. Maybe I should make a bigger diagram. Yeah, let me make it bigger and neater. This length is 10, this length is 15. I have to calculate the area of the trapezium in the question. This is 5. The area of the trapezium is, of course, equal to half into 10 plus 15. This area will be equal to half into 10 plus 15, which is 25, into height. How should I calculate the height? Very easy. Just drop a perpendicular from this. Just drop a perpendicular from this again. Yes, since both these were 5. This side is also 5. This side is also 5. This becomes a kind of rectangle. I drop the perpendicular. This, because they are parallel, all these 4 angles will be 90, which means from 15, this portion becomes equal to 10, which means this becomes equal to 2.5. And this also becomes equal to 2.5. Is this clear, Saundarya? And they become 2.5 each because this is an isosceles trapezium. This side is 5, this side is 5. It's a very symmetrical figure. And thus you'll get, they'll divide the perpendicular from this perpendicular from, we've taken this to be CD, from C as well as D, will divide 15 equally into 10, 2.5, 2.5. You can immediately get the height. The height will be nothing but under root of 5 square minus 2.5 square. Is this clear? And thus you can calculate. Use this value for the height and calculate the area of the trapezium. That is very good. The other question you'd asked is the question, the pentagon. That's also a good question, guys. This is again for everyone. So if you haven't solved this yet, I'm not very pleased that you haven't tried questions, but you can make that up a bit by solving this question. This is a regular pentagon, and using the base of a regular pentagon AB, the pentagon is ABCDE. Or using AB as base, you also have a square, ABPQ. and you have to calculate angle AQE. This angle you have to calculate. What's the value of angle AQE? We'll ask everyone to try. Yeah, yes, indeed. Lakshay knows the answer. Had I shared the answer key on this? We'll give you guys a couple of minutes to solve. Okay, let me solve it. What's the angle of a regular pentagon? Each angle of a regular pentagon is equal to 108. So if each angle is 108, and of course all these sides are equal, it's very important to note. AB is equal to AE is equal to ED equal to CD equal to BC, but also AB is equal to AQ, since ABPQ is a square, so all these sides are also equal. What does that mean? That means that this angle is 90 and this is 108 minus 90, 18 degrees. So let's just focus on this triangle right now. AQE with AE equal to AQ and this angle, small angle, being equal to 18 degrees. Yeah. If this is 18 and since these two sides are equal, then this angle, if this angle is theta, this angle is also theta, which simply means that theta plus 18 to theta plus 18 is 180, and thus theta will be 81 degrees, and that is what you need to calculate. You need to calculate this angle AQE, this angle. And your answer has to be 81 degree. I hope this answers, Saundarya, I guess this was your doubt. I hope that answers your question. Any other doubt, guys? Any other doubt in the last sheet on quadrilateral and polygons? You didn't understand this, Saundarya? Do you want me to repeat? Okay. What I am saying is all the sides here are equal. This is a regular pentagon, but since the square also is based on the same same side, the side of the regular pentagon, then this side is also equal to this side. Yeah, that is important because if you look at triangle AQE, the one I have made separately, angle EAQ, this angle and this angle here, little angle, is equal to 18 degree. It's equal to 18 degree because the interior angle of a pentagon is 108, and if you take away the 90 degrees of a regular of a square, then that only leaves 18 degrees. Yes. Now is this clear? In triangle AEQ, you have 18 degrees here. Since AE is equal to AQ, the other two will be theta each. They will be equal. That is what you have to calculate, theta, and theta you get as 81. Excellent. Okay, yes, indeed. Again, eighth is a good question. Lovely question, eighth. Any other doubt in this sheet other than eighth? I will definitely cover eighth. Okay. Again, for those who haven't tried questions here, would definitely recommend you try question 8. It's a beautiful question. Now, what does question 8 say? Question 8 gives you a rectangle ABCD, and then it also gives you the length of the sides. AB is 20, AD is 12, but there are other lengths that are equal to 12, drawn like this. Not going to be the perfect diagram, but nevertheless. this is MN, you have been told that DN is also 12. So this length is also 12, and that CM is also 12. This is also 12. That means DM is equal to 8, since AB is equal to CD equal to 20, and that CN is also 8, and thus that this length 8 plus 18, 16, MN must be 4. Yes, is this clear? Now, what else do I know? What else do I know about this? Yeah. Have a look at triangle. There are many ways of doing this question. What I like about this question is have a look at triangle MCB. MCB. MC is 12 and CB is also equal to 12. And of course, angle C is 90. Is this clear? So what does that mean? MC is 12, CB is 12. These two angles must not only be equal, both of them must be equal to 45. This angle is 45 degree. This angle is also 45 degree. Yeah. I'm showing you another quicker way of doing this question. You have to calculate in the question. You have to calculate the area of quadrilateral BO. This point is O. Let me mark O. This point is O. But I'm just showing a quicker way. So BONC is what you have to calculate. If you realize that this angle here is 45, and you also realize that this angle is also 45, because again, ND is also 12, AD is also 12, and of course angle D is 90. It means that angles opposite equal sides, 12, 12. This angle must be 45. This angle must also be 45. Yeah. Why is that important? That is important because I can simply calculate. Yes, indeed, Lakshay. Area, simply calculate area of triangle MCB and subtract from it area of triangle MON. And MON is actually a very simple, sweet kind of a triangle with this angle 45, this angle 45, and thus this angle must be 90. And we've just seen the 45, 45, 90, the ratio of it is 1 is to root 2. Yeah. So if this is 4, this will be 4 by root 2. This side, this will be 4 by root 2, or in other words, 2 root 2. This side will also be 2 root 2. And thus the area of this triangle MON will be half into product of the perpendicular sides, which is 2 root 2 into 2 root 2, which is 2 root 2 ka whole square. And area of triangle MCB is, of course, half into, again, 12 into 12. So half into 12 ka whole square. Now, does this solve? How do we get DM equal to CN equal to 8? See, we have been given that DN. Have a look at the question. DN is equal to 12. If DN is 12, then NC must be 8. This is a rectangle, so if AB is 20, CD is also 20. Yeah. So this is 12, leaves this 8, and MC was given to be 12, leaves that to be 8, and MN equal.